Even in making a simple fabrication, it's still important things be kept uniform, straight, flat, square, and undistorted. This is especially true if multiple fabrications are part of a larger assembly, where the dimension of one part relies on a neighboring part for its space and alignment. It's much more time and effort efficient to proceed with accuracy and uniformity than to continually have to go back and make corrections so things will fit properly. Angle iron notches can be made with an iron worker, torch, or plasma, just so the cut is done carefully to provide accuracy and the optimum weld gap. This notcher is an easy way to make a clean, precise knot. It's important to measure accurately and mark in a way that's easy to see. Silver streak pencils make a much narrower and more resilient mark than soapstone. The notched angle can be bent freely, but the radius of the bend to the outside will end up being quite a bit larger than the radius down at the notch. This will make the overall dimension off slightly. The angle iron can be tightly bent in a number of ways with a large vise, a bender, and so on, but doing it like this on the platen saves time and keeps everything flat as you proceed with the squaring and welding. Joining the leg in this way makes it easy to adjust the length exactly to that of the opposing leg by widening or tightening the gap where the two ends come together. If both sets of opposing sides of a rectangle are exactly the same length, then when the diagonal measurement is equal, the rectangle is exactly square. Overwelding can cause a lot of problems, and just starting at one end of the project and progressing with a series of welds can often create stress and warpage. By minimizing points of concentrated heat accumulation, while distortion can be minimized. So by rotating around the fabrication and allowing the last welded area to cool a little, excessive and localized hot spots can be avoided. It's not as important just how you proceed with the welding as that each joint is welded as consistently as possible in relation to the others so the distortion is kept consistent. A weld contracts more at the end than at the beginning, so for example, if you weld from the outside of a bend to the inside, you'll tend to close the bend a little, so you want to treat each joint equally. A little tack weld initially at the inside of the bend will help hold the alignment until the rest of the weld is finished later. There are lots of electrodes available, but in reality almost all structural welding can be done very well with either 6010 or 7018. Beyond this, Lincoln 6010 5P Plus and 7018 Excalibur are a little more expensive than other brands, but their quality and ease of operation make them worthwhile. 7018 has more elasticity, a faster deposit rate, and some additional qualities making it ideal for a well-prepared joint. The 6010 penetrates well and does a good job of preparing itself the best joint possible in rusty, dirty, ill-fitting arrangements. Both rods run well in all positions. In vertical joints, always weld up. The expanded metal can be cut with a shear, plasma, abrasive blade, or just with a cold chisel, not quite cutting into the table. The MIG with its concentrated arc is ideal for anchoring down the expanded metal, and the arc is mainly aligned toward the structural to some of the puddle involving the lighter section of the expanded. When the fabrication is complete, then a wire brushing will remove spatter, slag, sharp edges on the expanded metal. Once the welds are clean, you can easily check to see that they're not undercut or have other problems.